reactions in the intermediate levels, but in the final, in the end, they are remaining without any changes, without any, without being used up, they stay. So, those things are catalyst properties. Enzymes showing catalyst properties. Any catalyst, not only enzyme, any catalyst will do these works. One thing, a catalyst will reduce the activation energy. Okay, in your chemistry, you will study truly what is meant by activation energy. It is the barrier energy. It is the barrier energy to overcome, to perform a reaction. So what is activation energy? What is activation energy? Tell me, what is activation energy? It is the barrier energy. You know barrier? Do you know the word barrier?
Yes, sir.
Yes. It is the barrier energy a reaction should overcome to complete the reaction. Understood? For an example, now to perform best in the advanced level, you should have your barrier energy, the energy you want to overcome the stress, the challenge, the competition of the A-level examination is greater. If you have that much of energy only, you can overcome your barriers and complete the reaction, complete the performance, enter the university. Clear?
Yes, sir.
Right? So, for every reaction, now for any effort, okay, anything, now in your O level, you had a challenge, okay, you required a certain amount of energy. Without that level of energy, do you think that you could complete all 9 subjects? How much you hard worked for it? Yes or no? Did you complete your O level without any hard work?
No.
No. So you did a hard work. That is your barrier. The hard work needs energy. That amount of energy you want to overcome that hard work is activation energy. So what do you think after entering the advanced level? You want to, according to, I'm just commonly asking you this. You studied 9 chapters, 9 subjects in your O level. Here you are studying only 3 subjects only, correct? So I think you have already started to work on chemistry, physics chapters also. So what is your idea? What is your idea? Do you need more energy or do you need less energy? To
More
this
energy.
moment, what kind of attitude you have developed? Truly speak. What do you say? Do you need more energy or do you need less energy? What does your mind tells you? Amna?
Less energy.
Less energy. Very nice. Rima?
More energy.
More energy. Person to person, perception differs. Right? So after 3 months, we will ask the same question. We'll see how is your opinion. Right? So a certain amount of energy is required to overcome the barrier of hard work. And that energy required is the activation energy. Okay? Right. Let's speak in the other way. Now, inshallah, after your O-level result, you will choose a school and you will join that school for your further education. In that school also, the teachers are going to teach these chapters. But now already you have started following classes. I am asking one thing. Why do we want to follow classes when the say, now you have done that on the O-level also. This is not a thing that is justifying things, so demotivations, that's not the thing. I want to relate this idea to my enzymes lesson. Understood? Understood? I want to relate this one to my enzymes lesson. That's how I am bringing this. So, why do you follow classes? Any subject? You studied history, followed classes. Why do you follow classes? You followed classes, you're following classes. Why do you follow classes?
For extra support.
Pardon?
For extra support.
For extra support. That means the teachers in the tuition classes, compared to, it's not complaining about anyone, okay, compared to a school teacher, facilitate your learning process, decreases, okay, or they bring you a comfort learning in the subject, and you feel that they are guiding you towards the goal comparatively in an efficient way and an easier way. Am I right? I'm not speaking about my subject, I'm speaking in common. Okay? The purpose of what I feel is that regarding classes. Okay? The teachers are going to facilitate you, going to reduce your hardship, and they are going to guide you through a track that is more comfortable for you to achieve the same goal. Understood? Understood?
Yes, sir.
So this is what the enzyme does. So we can say the teacher decreases your hard effort. Say without teacher you are studying a lesson. Without teacher. Without teacher you study chemistry, say. Do you think it's easy for you?
No.
No, but can. Do you think it is can't? Do you think it is okay? You can't do that. Do you think you can't do that? Tell me.
Yeah.
Can. Why not? But only one thing. It will not happen in a quicker time. The teacher's experience, the teacher's knowledge, okay, all these ones are when it is incorporated, you are doing a quick learning. When you self-learn, it will take a longer time. Every word you have to study, everything you have to understand, correct?
Yes, sir.
Right? So, the teachers are reducing your effort. So, teachers are here working as enzymes. They are reducing your activation energy, your barrier energy. Understood?
Yeah, sir.
Same time, at the end of the reaction, now I started my A-level biology classes in 2003, soon after my graduation from the university. 2003, now 2022. How many years? Approximately 19 years. Okay, continuously teaching biology. Every year, that's a batch. Every year, syllabus is changing, but continuously teaching. Every year, students pass out. Okay, every year, new students join. This is a journey. So, point it is, at the end of, now I am conducting your class 2024 batch. So 2024 batch, after it is completed, I will be remaining as the biology teacher working for the next batch. Yes or no?
Yes, sir.
Yes. So that means there's no changes in me. Okay, I am not getting consumed by the reaction. The enzymes are not getting consumed by the
Reaction.
Okay, changes are in you, changes are not in me. I have to be updated, but continuously staying as a A-level biology teacher. Right. So these two properties are normal catalyst properties. Any catalyst, they do these two things. What are the two common characteristics of a catalyst?
Reducing the activation energy.
Reducing the activation energy,
Not being consumed by the
not
reaction.
being consumed during the reaction. Okay. Enzymes are macromolecules. You need to put this portion in the bracket. Which one? Which one?
Made up of globular protein.
Made up of globular proteins. You have to put the brackets between them. Made up of globular protein. Put the brackets. Okay.
Okay.
In the bracket on top, above, you write mostly made up of, what is it?
Globular protein.
Globular proteins. Okay. Completed.
Completed, sir.
Right. Now, what are the characteristics of enzyme. One of the characteristic of enzymes, most of them are what is written here?
Globular proteins.
Globular proteins. Why? Now in exam paper, so in notes, if the examiner uses the word most, we have to understand it is not all. Understood?
Yes, sir.
All is not there. Why? It is pointed that way. Now, in our O level also, we studied, what is it? Enzymes are proteins, correct? Yes or no?
Yes, sir.
Yes. Point it is, some RNA function as, what is it?
Enzymes.
Enzymes. Example, rRNA. You studied RNA, no? In
Yes, sir.
chemical basis of life. rRNA can function as enzyme. Enzyme reducing the activation energy, not being used up in the end of the reaction. If those two properties are there, it is an enzyme, correct? So why do these people tell most of the enzymes are globular proteins? Mean not only proteins, some RNA molecules also function as enzymes. Clear?
Yeah, sir.
Complete it, complete it. Have you completed?
Yes, sir.
Right. Second thing it is, you are pointed, they are biological catalysts. That means they reduce the activation energy, correct? They reduce the activation energy. They are not used up during the biochemical reactions. Because they decrease the activation energy, the speed, the rate of biochemical reactions are increasing. Okay, that is another property. The third property, most enzymes are heat liable. Okay, sensitive. The enzymes, now, if the enzyme is protein, remember, you know, enzymes can be protein, enzymes can be, what's it?
RNA.
Proteins are denatured by heat. Do you know that one? Proteins are denatured by heat. Do you know that one?
Yeah, sir.
Yes. So, heating can denature an enzyme. If the enzyme is denatured, it will lose its catalytic nature. Catalytic catalytic function will be lost. Understood?
Yes.
Yeah.
And that is the one here they say most enzymes are heat liable, or some hate labile or heat sensitive. They can't, they are easily, their function can be altered by temperature. Okay. For every enzyme, because they are heat sensitive, there will be one temperature that make them function at best. And that temperature is called by the name their optimum temperature. What is optimum temperature? What is optimum temperature? In that temperature, a particular enzyme will work at its best. Understood?
Yes, sir.
Yes.
Yeah, sir.
Enzyme to enzyme, optimum temperature will differ. All the enzymes don't have, what is it? Same optimum temperature. Enzyme to enzyme, optimum temperature will differ. But if you give optimum temperature, enzyme's function will be at its
Best.
best. Understood?
Yes, sir.
Good. Next point you are told, enzymes don't alter the nature or quantity of the end product of any reaction. Okay? Enzymes, they don't alter. Now say, in a chemical reaction, now say you have some starch. Say you have some, what's it? Starch. To that starch, you put some water. Now, starch and water will react. That reaction will give you maltose. What is the product of reaction between starch and water?
Maltose.
Maltose. If you mix starch and water, maltose will be formed. Okay. Now say you are getting 5 milligram maltose. To get this 5 milligram maltose, a minimum of 24 hours will be needed. Understood?
Yeah, sir.
To the starch plus water medium, if you put amylase enzyme, to get this 5 milligram maltose, half an hour would be enough. What is the difference? Does the 5 milligram change? Because you put amylase enzyme, do you change the amount of maltose you get?
No.
No.
No. Do you get a different product other than maltose because you use amylase enzyme?
No.
No. Same maltose coming, same 5 milligram coming. Only difference is without amylase, it is taking a longer time. With amylase, the same target is achieved in shorter time. Understood?
Yeah, sir.
So enzymes, that's why they say they don't alter the nature. That means maltose with water, starch is reacting with water, maltose is coming mean because enzyme is there, another product will not come. Maltose will come. 5 milligram maltose can come mean with the amylase also 5 milligram only will come. Only difference is without enzyme, it will take longer time. That means rate is low. With enzyme, it will take a shorter time. That means rate is high. Understood?
Yeah, sir.
Good. Thereafter, another point you are given, they are synthesized in living cells. That is okay. All the enzymes are biological molecules. They are synthesized in living cells. But in bracket, what is written to you? In brackets, what is written to you?
In ribosomes.
In ribosomes, correct? That is fitting only for the protein. Understood?
Yes, sir.
In ribosomes, proteins are the ones produced. If RNA can function as an enzyme, RNA or rRNA is not produced in the ribosome. It is produced inside the nucleus. That is the truth. You studied that one in cell biology. So it is true, they are synthesized in living cells. So what you have to write here is in ribosomes, above that one, write it down, majorly in ribosomes. Majorly in, what is it?
Ribosomes.
Majorly in ribosomes, because most of the enzymes are proteins, no? Correct?
Yes, sir.
So although we point out RNA can work as an enzyme, in throughout the whole syllabus, if you go for the enzymes we study, all of them are proteins. We don't study any RNA enzyme. Understood?
Yes, sir.
So next it is, enzymes are highly substrate specific. Now, if you take a teacher, teachers are subject specific, correct?
Yes, sir.
Teachers are, what is it? Subject specific. Different teachers have mastered themselves in different subjects. Okay? Now, for an example, if I teach you history, that will be the most boring lesson for you. Understood? If I teach you history, that will be the most boring lesson for you. Why? I am not specific to, what is it?
History.
History. But there are teachers who are very interestingly teaching history. Am I right?
Yes, sir.
So, teachers are substrate specific. But remember, there are teachers can do two subjects like, okay, up to 2018, I was teaching chemistry and biology. Okay, but really hard to maintain time and preparations for both. After 2018, I decided to discontinue the chemistry part. Now fully working only in biology. Point it is, I was specific to how many subjects?
Two subjects.
Two subjects. That is possible with an enzyme also. One enzyme can be specific to two subjects, two substrates, but only those two. Understood? Give me 1 minute time, I'll come back. Okay, thank you very much for waiting. Right. So, do you understand this wording? Enzymes are highly, what is it? Highly
Substrate specific.
substrate specific. Okay, enzymes are highly substrate specific. Now, amylase enzyme can work on starch. Sucrase enzyme can function sucrase. Sorry, sucrase can work on sucrose. Okay. Who can work? Starch. Okay. It is worked by which enzyme?
Amylase.
Amylase enzyme. Sucrose is worked by which enzyme?
Sucrase enzyme.
Sucrase enzyme. My question here is, okay, if you put amylase to starch, it will speed up the conversion of starch to maltose. If you add sucrase, it will speed up the conversion of sucrose to glucose and what is it? Fructose. My point is this: you change the enzyme, you put the amylase to sucrose solution. Will sucrose turn into glucose and fructose speed up?
No.
No, it will not speed up. Clear?
Yes.
Are
Yes, sir.
you clear? Because sucrase only can speed up the reaction of sucrose turning to glucose and fructose. To that place, if you bring amylase, will it work?
No.
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 Opposite also not possible. If you put sucrase to starch, will starch converting to maltose speed up?
No.
No, it will not speed up. Okay, are you clear?
Yes, sir.
So actually it is like a lock and a key. It's lock and a key. In a key, you all of us have seen a key. In a key, there will be a particular shape, correct? A geometrical shape will be there, correct? A particular shape will be there. If you insert the key inside the lock, its opposite shape is there. Understood?
Yes, sir.
For an example, in the key, if this kind of a shape is there in the key, in the lock, okay, to fit with this kind of a shape will be there. This particular key has to fit with it, no? Correct? As a filling work will be there, filling part will be there. The filling part will be there. This piece will go and fill there. Understood? Understood?
Yeah, sir.
Will go and fill that. That is called by the name complementary nature. Which kind of nature? Which kind of nature? Complementary nature. Right? For a simple example, here this pen. This is the nib part of the pen. This is the lid of the pen. You can lock like this, correct? Yes or no? Yes. This one's shape and this one's shape are fitting with each other like this, correct?
Yes, sir.
That's why they lock. So we can say this shape and this shape are complementary. What kind of nature? What kind of nature?
Complementary nature.
Complementary. One fitting with the other. One fitting with the other. Okay, complementary doesn't mean one is equal to the other. Is this one shape and this one shape, are they equal?
No.
No. One is fitting with the other. One is filling the other. One is complementary to the other. Clear? Are you clear?
Yes, sir.
Good. So that now if you insert a wrong key, okay, now to this pen, if you insert this lid, okay, are they fitting properly? Are they locking? Now see, are they locking? Like this. Will that lock piece coming?
No.
No. That mean they are not complementary. This is belonging to another pen. In that one, you can hear lock, correct? If I insert it here and press it, do you feel I can just press it inside. I can just forcibly press it inside. Is that mean they are fitting?
No.
No. So, this geometry and this geometry are not equal. But this one geometry and this one geometry are equal, they fit. Clear?
Yes, sir.
Good. So enzymes are highly substrate specific. In them, there are places called, what is it? What is the name of the place? Active sites. They have a specific geometry. Substrate has to join that active site. There only reaction takes place. Understood?
Yes, sir.
Right. So what about the active site geometry and substrate geometry? They are, use that word, they are
Complementary in nature.
complementary. Good. Okay. The geometry are complementary. Next point. Okay, cut and remove this one. It's accidentally that word has fallen there. That's not a part of it. Most enzyme catalyzed reactions are, what is it?
Reversible.
Reversible. Reversible mean? Reversible mean, okay. Now take this one, or we can write this part here. Starch, okay, reacting with, what is it? Water and forming, what is it?
Now,
Maltose. This reaction is reversible. Reversible mean starch and maltose can form, what is it? Water. Sorry. Starch and water can form maltose. Maltose can form. Tell the
starch
opposite.
and water.
Starch and water. Understood?
Yes, sir.
Starch and water can form maltose. Opposite. Reverse. Maltose can form, what is it?
Starch and water.
Starch and water. Okay. Generally, reversible arrows we use to show that one. Reversible arrows will come like this. Understood?
Yes, sir.
So in that place, you write that reaction and show with the reversible arrow. You took the printout, no?
Yeah, sir.
Right. Another property you are given. Enzyme activity can be affected by many factors. What are the factors affecting the enzyme activity?
Temperature,
Temperature,
substrate concentration,
substrate concentration,
pH of the medium,
pH of the medium,
heavy metal ions,
heavy metal ions,
high electric potential,
high electric potential,
high pressure.
high pressure. If you take the last three, what are the last three?
Heavy metal ions,
Heavy metal ions,
high electric potential,
high electric potential,
high pressure.
those kind of factors, okay, they involve in denaturing of proteins. What is the role of them? What is the
Denaturing,
role of them? They denature, what is it?
Proteins.
Protein. As most of the enzymes are proteins, those three presence. If heavy metal ions are present, if high electric potential is present, if high pressure is present, okay, enzyme will be denatured. Denatured enzyme will not function. Understood?
Yes, sir.
Right. That's all about them. We don't need to put lots of load about them. What can you write? They denature proteinous, what is it? Enzyme. They denature proteinous enzyme. So enzymes lose their catalytic, what is it?
Function.
Function. For those three, you can put the wording there. Okay.
Okay, sir.
Some enzymes require non-proteinous components to catalyze the reaction. Support. Okay. What are the names of this non-proteinous component? Read this word.
Cofactors.
Factors. So who are cofactors? They are non-proteinous components required to
Catalyze.
yes, required by an enzyme to perform its catalytic action. Understood? They want to do the catalytic action. To do that catalytic action, they need the support of another molecule. And that other molecule is called by the name cofactor. The cofactors are not proteins. Understood?
Yes, sir.
Good.
Yes.
Anyway, you have small correction there. ATP, though it is a cofactor, it has been removed from the place of cofactor in your syllabus. ATP can function as a, what is it? Cofactor. But your syllabus doesn't support it. So cut the ATP, keep the rest. NAD plus, K plus, you can include further FAD. FAD, can you remember FAD?
Yes.
NADP plus. Like examples, you have to include. Okay. And who you have to exclude?
ATP.
ATP. ATP truly can work as a cofactor, but our syllabus doesn't take ATP as a
Cofactor.
uh, okay.
Okay, sir.
Right. Another property, you know that one, enzymes are not used up during the reaction. At the end of the reaction, at the end of the reaction, they will be remaining as they are. No any amount will change. No any chemical property will change. Understood? That is, they are not used up. Because they are not used up, as they are renewed again, and again, small quantity of enzymes are sufficient. Understood? Understood?
Yes.
Further, that is not too much important for you. Enzymes don't change the equilibrium point of a reversible reaction. That is the general behavior of a catalyst. Okay. Further, enzymes don't change the delta G or delta H of a reaction. Now, the change in the energy. What is delta G? What is delta G? The change in the, okay, delta, you have to mark that letter. Delta G means, okay, free energy of products minus free energy of home
Reactants.
reactant. Now, for every reactant, there is an energy level. That energy amount, enzyme doesn't change it. Okay. A is turning to B. A has 1000 joule free energy. B has 800 joule free energy. What is the change in energy when A becomes B?
200 joules.
200. With or without enzyme, that 200 will be there. Understood?
Yes, sir.
Are you clear what I told you? With or without that one, it will not change. Delta H means heat energy of products minus heat energy of home
Reactants.
reactants. In that case, in that case, also the heat energy with or without reactant products, heat energy will be stable. Reactants heat energy will be stable. Understood? So, can an enzyme alter delta G or delta H?
No.
No. Delta G or delta H cannot be altered by
Enzyme.
enzyme. Understood? If you want, I can put these details there. It will be useful for you to have you marked it?
Yes, sir.
Good, good. So, this is a picture in our syllabus showing the effect of enzymes on rate of reaction. What is this? Is in our book, this is in our syllabus. So, what is the word written here?
Free energy.
Free energy. Free energy means GOH. Free energy means GOH.
G.
G. So, this is the free energy of whom?
Reactants.
Give me a minute, getting a call. Okay. So the black line shows you, this height. This is the barrier energy without the enzyme. This is the barrier energy with the enzyme. Where does it require less barrier energy? With enzyme or without enzyme?
With enzyme.
With enzyme. If you take this line is the this line is the free energy of the reactants. This is the free energy of the products. Mark these two. Free energy of the reactants and free energy of the products. Okay.
Done, sir.
Right. So according to this, reactants are in their place. Correct? With or without enzyme, is there a change in the free energy of the reactant?
No.
No. Products 1. Is it getting altered?
No.
Product not altered. That means the difference in the free energy, is it changing with and without the presence of enzyme?
No.
No. Are you clear?
Yes, sir.
Right. But activation energy, what is happening to the activation energy with the presence of enzyme?
Reduces?
It reduces. Activation energy reduces. Clear?
Yes.
Good. That you have to understand from this. Enzyme reaction mechanism. Hereafter, we are going to speak about the how an enzyme functions. Right. The first thing they say, reactant and enzyme act on it is referred to as, okay, you put this word, cut this word and write duct. End is a wrong point. The reactant that enzyme acts on is referred to as, what is it?
Substrate.
Substrate. the reactant, that enzyme exon, is referred to as, what is it?
Substrate.
Substrates. Right now, starch is converted to maltose by amylase. In that reaction, who is the substrate?
Starch.
Starch. On starch only, who works? Enzyme. Then starch is converted to
Maltose.
maltose. That is called product. Maltose is called by the name, what is it?
Product.
Product. Are you clear?
Yes, sir.
Right. When enzyme meets a substrate, can you see this picture? What is this one pointed to you? What is it? That green color part?
Substrate.
Substrate. What is this? The larger one?
Active site.
Enzyme. The larger one is whom?
Enzyme.
Enzyme. In the enzyme, one place is called
Active site.
active site. Substrate binds to the
Active site.
active site. After they join, the total unit is called enzyme substrate complex. Clear?
Yes, sir.
So simply note tells you like this. The enzyme binds to its substrate forming home.
Enzyme substrate complex.
Enzyme substrate complex. If remember, if the enzyme substrate complex cannot be formed, catalytic action will not take place. Understood?
Yes, sir.
If the enzyme substrate complex is not formed, will there be catalytic action?
No.
No. It is within that place. Okay. Substrate is converted to
Product.
product. Are you clear?
Yes, sir.
Yes. Fourth one is simple point to you. Enzymes are substrate specific, you know, correct?
Yes, sir.
Yeah. So if that enzyme is there only, that particular reaction will be catalyzed, correct?
Yes, sir.
Yes. Specificity of enzyme results from its shape. Whose shape? Whose shape? Whose shape? Is it
Yeah.
enzyme shape? No. It is the shape of home.
Active site.
Active site. Active site shape and enzymes shape should fit with each other, should be complementary. Understood?
Yes, sir.
The substrate binds to a specific region of the enzyme, and that region is called by the name. That region is called by the name
Active site.
active site. Are you clear?
Yes, sir.
Right. Active site is formed only of few amino acids. Okay. Other amino acids are needed to maintain the shape of the enzyme molecule. The shape of the active site is complementary to the shape of the specific substrate. Understood? Do you understand the word complementary?
Yes, sir.
Do you understand the word complementary? They are matching, complementary. One is filling the other. But in that filling, there's a small adjustment. Look at this. Look at this diagram. Can you see the active site?
Yes, sir.
Yes. Can you see the substrate?
Yes, sir.
Yes. When this substrate come and join here, according to your view, is the substrate and active site are 100% matching like a lock and key? Are they matching?
No.
No. When the substrate join, somewhat matching will be there. Additional matching will be done by the enzyme by altering the shape of the active site a little. Understood?
Yes, sir.
Okay, it's almost like a life. Not a good example telling it's a life. Now, in any person's life, don't take this one. You are little mature people. I think I speak to some mature people. Okay, not to small children. Now, when a person gets married, he looks at the partner, male or female. They look at the partner and they decide that person is matching for them, and they get married. But after marrying, okay, each of them will find their weaknesses, correct? Yes or no?
Yes, sir.
So after they find their weaknesses, they will go on in the life adjusting with each other, correct?
Yes, sir.
100% matching husband and wife are not available in this world anywhere. Each of them are adjusting. Here there are some weakness, there are some weakness, they are adjusting. But 70% matches, they are mean 30% adjustment. Clear?
Yes, sir.
Similarly, substrate in active site, 70% matching mean another 30%. Who will adjust? Who will adjust?
Enzyme.
Enzyme will adjust. Are you clear?
Yes, sir.
Yes. It is the one told to you. The shape of the active site is not fully complementary. 100% complementary, 100% matching. Is it possible?
No.
No. 70%, 80%. Then to bring it to 100%, who has to adjust?
Enzyme.
Enzyme has to adjust. When they bind, before binding, they will not adjust. After binding only, they will
Adjust.
adjust. Okay. So, if the enzyme is adjusting, can you describe them as rigid structures?
No.
No, they are flexible structures. Correct?
Yes.
Yes, they are adjusting. The interaction between substrate and active site can slightly change the shape of home,
Active site.
active site, so that the substrate and active site become complementary to.
Each other.
That means full complementarity is possible only with adjustment. Understood?
Yes, sir.
And that is described by which wording?
Induced fit mechanism.
Induced fit mechanism. Okay, they bind when they are not 100% complementary. Enzyme and its active sites are slightly changing, well fitting with the substrate. Right. The tight fit, not only now they are because of this, because of induced fit. Can you see the substrate and enzyme now tightly fitting? Correct? Can you see here? They are tightly fitting. The tight fit, what are the benefits of this tight fit? This tight fit is bringing the substrate molecule and active site close to each other. It ensures the correct orientation of the molecules to help the reaction to proceed and catalyze the conversion of the substrate to the product. We will try to understand this. Now, first thing is okay, no? The tight fit between the substrate and the enzyme bring the substrate and active site close to each other. Do you agree with it? Do you agree with it?
Yes, sir.
Yes. Second one, I have to little explain you. Actually, it is the here they say, let's say like this. Here there is A, B, a molecule. It is reacting with C, expecting to form AC and separating home. Separating home, the B. Now, to AB, if the C go and contact from this side, this is one orientation to AB. If the C goes and contact this side, this is another orientation. Which orientation will make this product you think?
First one.
First one is contacting with the B.
Second one.
The second one. So to make a product, two reactants just meeting is not enough. They have to meet in the correct orientation. Understood?
Yes, sir.
Wrong orientation will not give you correct product. Wrong orientation will not give the product. Understood? Understood.
Yes, sir.
Yes. So it is enzymes role play directing the substrate in the correct orientation. Understood?
Yes, sir.
Directing the substrate in the correct orientation is whose role play?
Enzymes.
Enzymes role play. For that one, enzyme should be very closer to the substrate. Understood?
Yes, sir.
Third one,
Yes, sir.
as usual, it is decreasing the activation energy, catalyzing the reaction. So that is understandable. So this point is understandable. Yes or no? Brings the substrate molecules and active sites close to each other. Is it understandable?
Yes, sir.
Second, catalyzing the conversion of substrate to the product. Catalyzing means reducing the activation energy. Is that understandable?
Yes, sir.
The middle one is the substrate molecules are directed in the correct orientation. If the correct orientation is there only, the product will be correctly formed. Are you clear?
Clear, sir.
Thereafter, now anyway, now with all these, now the product has formed. After the product is formed, is there any need of the enzyme?
No.
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 After students complete their goal, now my students are there last year. Okay. This year, 2 people got medicine. Last year, 3 people got medicine. So now I am in touch with them. But now they have gone to the 2020 batch has gone to the university. They are in the university. Do they need me?
No.
No.
Sir.
My role is over, correct? My role is over. I detached from them. And again going on with some new substrates, correct?
Yes, sir.
Going on with some new substrates. So when the product is formed from the active site, the product will be detaching. Look at this picture. The product is, what is it? Detaching. Active site is coming to normal. Normalized active site will again attack a new substrate. Understood?
Yes, sir.
Are you clear?
Yes, sir.
Please go through the enzyme reaction mechanism and tell me whether everything is clear.
Clear, sir.
Clear. Thereafter, we come to the heading called, what is it? Cofactors. Already that word is a new, not a familiar word to you, correct? Cofactor. Cofactors are proteins or non-proteins.
Non-proteins.
Non-protein, they are not proteins. And they are necessary, they are needed by, they are necessary for whom?
Certain enzymes.
Certain enzymes. Enzymes want it. If this cofactor is there only, I can do my catalytic function. If this cofactor is absent, I can't do my, what is it? Catalytic function. It is their demand. Now there are children telling, what is it? If Dada is at home, okay, Dada is there only, I will eat. Okay, they place a demand, a necessity, an essential. If this one is there only, I will do this. Okay, it is a demand of whom? It's a demand of whom?
Certain enzymes.
Certain enzymes. Enzymes are doing it. In the enzyme cofactors, some, now there are this, just I took this picture. This is the proteinous part of the enzyme. Apoenzyme. Those words are not in syllabus. No need to go in detail there. Apoenzyme. So cofactors, coenzyme, all of them are cofactors. Some cofactors bind to the enzyme tightly and remain, what is it?
Permanently.
Permanently. Some of them are bind to the enzyme loosely and remain
Temporarily.
temporarily. Are you clear?
Yes, sir.
Yes. Some of them are lifetime. They will be with the enzyme. Some of them they will attach and detach. Understood?
Yes, sir.
Right. Among these, there are two types of cofactors. Organic cofactors there. Inorganic cofactors there. Okay, organic cofactors are there. And what is it? Inorganic cofactors are there. Organic cofactors has a name called coenzymes. Okay. Inorganic cofactors have a name called ion activators. Right? Anyway, as I told you, ATP has been removed from, what is it?
Syllabus.
Syllabus as a cofactor. ATP has been removed from syllabus as a, what is it? Cofactor. ATP is in syllabus. ATP is not taken as a
Cofactor.
cofactor. Most vitamins, vitamin derivatives are coenzymes. Biotin, ascorbic acid like vitamin C, vitamin derivatives like NAD plus, NADP plus, coenzyme A. FMN is not in syllabus, remove that one also, not necessary. Remember, you have to understand certain things not in syllabus mean, please remove it. Don't take that one serious. Okay. Understood?
Yes, sir.
Yes.
So, if anything, so you might ask, sir, is your tute? No, yes, my tute. So, you know, I was adjusting this tute to give you in 2024 batch, to give you, I was adjusting, I took little time. some adjustments are not yet completed. That's why those 2 to 3 points I have to, kuti points I have to remove. Understood?
Yes, sir.
Right. Fine. Ion activators, the syllabus book says 3 ion activators in example. What are the 3 ion activators? Zn2 plus, Fe2 plus, and what is it? Cu2 plus. From the syllabus, I have picked these enzymes. These are enzymes. What is the enzyme using Zn2 plus as ion activator? What is the enzyme using Zn2 plus as ion activator?
Carbonic anhydrase.
Carbonic anhydrase. What is the enzyme using Fe2 plus as ion activator?
Catalase and
Catalase and nitrogenase. And what is the enzyme using Cu2 plus as ion activator? Cytochrome oxidase. Cytochrome, what is it?
oxidase.
Oxidase. Understood?
Yes, sir.
Yes. So, here I have written a point. Many contain AMP as their base. That means many of them are, many of the coenzymes are nucleotides. Mark that point. Many of the coenzymes are whom?
Nucleotides.
Nucleotides. Now see, NAD plus is a coenzyme. NADP plus is a coenzyme. FAD is a coenzyme. Coenzyme A is a coenzyme. All of them are nucleotides. Understood? They have AMP, adenosine with them, mean they are nucleotides. Adenine based nucleotides. Okay. Have you completed it?
Yes, sir.
Okay, inshallah, we'll meet. I think before we meet next time, your OL results will be out. We hope so, inshallah.